Hey there guys, welcome to the 2.5 video notes for solving absolute value inequalities. Now, solving absolute value inequalities is very similar to solving absolute value equations. The steps mostly are the same. You still start by isolating your absolute value expression, which means you have to get your absolute value bars by themselves, nothing in front, nothing afterwards. We still have to be careful about the negative cases. So if I get an inequality that's negative, I may end up a case where it's no solutions, but the difference between equations and inequalities, when I have inequalities, I might get no solutions for negatives, but I also might get all real numbers. And we'll see in an example what's the difference between having a no solution case and an all real numbers case. Now, if they're not negative, you solve it just like normal. You separate your absolute values into two different equations, the positive case and the negative case. You solve. And the other extra thing about inequalities is that we have to graph its solution, which means we have to draw number lines. So before we even do any math, let's talk about number lines and the difference between a less than inequality and a greater than inequality. Now, when we do inequalities, there's a specific way we write our answers. When we did equations, we wrote them in set notation, where we use the curly brackets, your number, comma, your number, curly brackets. We're going to have something called an and and or case, which will tell us how we need to write our answers. Now, if it's less than, then you have a case of an and case. Which, some way that you can remember it is less than. Wow! So in this case, if we have less than or equal to or just strictly less than, we have an and case, less than, which tells us what we need or what format we need to write our answers. So we look at our first problem here. It's already solved for us. We say, okay, well, our answers are -4 and 4. It's strictly less than, so we have open circles. So now we need to write our answers. Now there's two ways to write your answers using inequality and interval notation. So I'm going to write both. So inequality and interval notation. Inequality notation means, hey, keep your less than and your greater than symbols. So if it's an and problem, we're going to combine them because it's this and that. Or another way to say is my x is all values between -4 and 4, which makes sense. -2, the absolute value of -2 is 2. 2 is less than 4. +3, the absolute value of +3 is 3, which is less than 4. And if I choose a solution outside of values between -4 and 4, for example, +5, absolute value of 5 is 5, which is not less than 4. So all my solutions are between -4 and 4. So what I'm going to do is I'm going to write -4 less than, since it's strictly less than, x less than 4. So that's how I write my answers using inequality notation. For interval notation, same idea, except interval notation is where I use my parentheses or my brackets. So in this case, first off, since I have strictly less than, not equal to, I'm going to use my curved brackets or my parentheses, and you'll just write -4, 4. Careful, this is not a coordinate point. It is just your solution set. So we're going to try this again with this number line right here. We're going to use inequality notation, and we are going to use interval notation. So in this case, I can see that my values are between 4 and 10. So I'm going to write my values between 4 and 10. Now we still have open circles, so we're still going to just write strictly less than. So my x values are between 4 and 10. And for interval notation, it's kind of shorter. You get rid of the x and you get rid of the inequalities and add parentheses. So that's an and case. Now we need to talk about an or case. We have an or case when we have greater than or greater than or equal to. One way to remember it is if we have a greater, we have an or case. Less than, and case, greater, or case. Very neat, very cool. So in this case, we're going to write our answers in a different format because it's telling us something different. So in this case, this is an or case. So what this is saying is, hey, I can be greater than 4 or less than 4. So for example, if I choose the values that are in between, and I know this looks a little bit confusing, what it's really saying is that we want to be going this directions. If I choose any of these values again, So for example, the absolute value of 2 is 2. 2 is not greater than 4. If I choose negative 3, well, the absolute value of negative 3 is 3. 3 is not greater than 4. I have to choose values that are outside, going in opposite directions. For example, 5, the absolute value of 5 is 5, which is greater than 4. The absolute value of negative 5 is 5, which is greater than 4. Ooh, pretty cool. So since we're no longer being in between negative 4 and 4, in fact, we're going from opposite directions from negative 4 and 4, we need to write our answers in a different format. So for OR cases, we still have the inequality notation and the interval notation, but they do differ. So for inequality notation, I'll have, okay, my x values can be less than negative 4, because I want negative 5, negative 6, negative 7, all of those works. Or my x values can be greater than 4. 5, 6, 7, 8, 9, 10, all work. So for OR cases, it's pretty straightforward. You just have your two answers and you put an OR. For an AND case, you just squeeze them together because it's in between those two values. Now for interval notation, we're going to write it. We're going to say, okay, well, if I want every value that is less than 4, it's going to go all the way to the negative infinities till my negative 4. And then it's a parentheses because it's strictly greater than, not equal to. We're going to use a new math symbol. This is your symbol union, which means it's basically OR in math notation. And then 4, we're getting greater than 4, so I want all values greater than 4, so we're going towards positive infinity. Those are my two answers. So we're going to do the same thing over here, same idea. We're going to have inequality and interval notation. And we can see, okay, so for my inequality notation, I either want to be less than negative 6 or greater than 2. So x can be less than. Now this time it's going to be equal to, because I do have a filled in circle, less than or equal to negative 6. This is an OR problem. Or x greater than 2 or equal to 2. And same idea down here. We go from negative infinity because my values are from negative infinity all the way to negative 6. This time I'm going to have a bracket or a square bracket because I am equal to. I have closed circles. Anytime you have an OR case, you need to use a union symbol. 2 to positive infinity. So for the most part, for these problems, they're very similar to solving absolute value equations. This is really mostly the only new added part, which once you get used to telling the difference between AND or OR cases, it becomes pretty straightforward. But let's do some actual math. So we have our example 1, and we have our steps here to the side so that we can use it to help us follow along. Now we're still going to start the same way. I'm going to start by just writing my original equation. And I need to isolate my absolute value. So I need to get rid of this minus 6. I'm going to add 6 to both sides. And that's going to give me absolute value of x plus 4 greater than 15. Very cool. Now that my absolute value is isolated, there's nothing after it, nothing before it, besides the other side of the equation, I can start separating it into its two compound inequalities. So we're going to write x plus 4 greater than 15. This is my positive case. It's exactly the same. I just get rid of the bars. And x plus 4. Now this time, when I write my negative case, not only do I write the number or my answer as a negative, but I also have to flip the inequality symbol. So be careful. Now I kind of skipped step 2, is the number on the other side negative. Before you separate, you have to look at your answer. Is it negative? In this case, no. So you can go into step 3, which is what I did, set up your compound inequality, which just means make your positive and negative case. And from here, just solve like normal. Subtract 4 from both sides. X greater than 11. Subtract 4 from both sides. X less than negative 19. Now you might say, okay, this is my answer. Well, we have to write it either as an AND or OR case. And you can tell if it's an AND or OR case right before you separate, once you've isolated your absolute value. So not the beginning, once you've isolated it, you look at your symbol. And this symbol is a greater. So it is a or case because of this symbol. So that tells me if I'm going to write it as inequality notation, and I'm going to write, usually we like it from least to greatest, so x less than 19, or x can be greater than 11. And then for interval notation, I'm going to use the union because it's an or case. So negative infinity, negative 19, parentheses because there's no equal to, union, 11 to positive infinity. Those are my two answers, whether I write it in inequality or interval notation. It's important to know how to write it in both notations, although you won't always have to write it in both notations. So we set it up, we solved. Our last step is to draw our number line. So I'm going from negative 19 to 11. Now these circles will stay open circles because it's strictly less than and strictly greater than. And since it's an or problems always face away from each other. So I can be less than negative 19 or greater than 11, but not in between. All right, that's not bad, hopefully. There is a typo in number 3. Whoops, my bad. That 3 in front of the absolute value used to be gone, like it was never there. And that negative 9, my bad, is actually a negative 3. So please change that before we start the problem. Otherwise, you'll be confused. I'm going to rewrite the new problem. So we have to isolate my absolute value. So same thing as last time. I need to add 7 to both sides to get the absolute value by itself. So 2x minus 1 greater than equal to 4. Perfect. Now that is isolated, I need to check, okay, is the number on the other side negative? No. So I can go on to step 3, which is write my positive and negative case. So 2x minus 1 greater than or equal to 4 stays exactly the same, just get rid of the absolute value bars. 2x minus 1, flip your inequality, and write your negative case. So that positive 4 now became negative 4, and that greater than or equal to is now less than or equal to. And now I need to solve. So solve like normal, I'm going to add 1 to both sides. 2x greater than or equal to 5. Divide by 2 on both sides. X greater than or equal to 5 halves. Which is okay, sometimes you will get fractional answers. On my other side of my inequality, same idea, add 1 to both sides. And divide by 2 on both sides. So I get x greater than or equal to 5 halves and x less than or equal to negative 3 halves. Then I go right up to my problem right before I separate it when my absolute value is isolated. And I check, okay, what symbol do I have? Well, this is an OR case again. It's great OR. So I need to write it as an OR problem. So greater than or equal to still count as OR cases. So for my inequality notation, I'm going to write from least to greatest, x less than or equal to negative 3 halves, or x greater than or equal to 5 halves. And for my interval notation, same idea, negative infinity, comma, negative 3 halves, union, 5 halves, comma, infinity. That's always a setup. The only thing that will change for OR cases are these numbers here. Otherwise, the negative infinity, the union will always be there. And the parentheses. If it's equal to, then we need to have square parentheses, which we do have in this case. So these actually have to be brackets because of the equal to. My number line, same idea. I'm going from negative 3 halves to positive 5 halves. This time I'm going to fill in my circles because it's equal to. But since it's an OR case, they still face away from each other because I can be less than -3/2 or I can be greater than 5/2. All right, 2 more examples. So for example 3, still the same idea. I'm going to write my problem. 5x plus 6 plus 4 less than 1. I want to isolate my absolute value, so I'm going to subtract 4 from both sides in this case. I'm going to get absolute value of 5x plus 6 less than -3. Step 2 is the number on the other side negative. So I've isolated my absolute value. Is this number negative? Whoops-a-daisy, it is indeed negative. So let's think about this case. Absolute values are always going to give me positive numbers, so I'm just going to write this. Is it true that positive numbers are less than negative numbers? Because no matter what I put in here, it's always going to give me a positive number. So if I do -10, that gives me -50, plus 6 is -46, or -44. Absolute value of -44 is 44. 44 is not less than -3. This is a false statement. So, absolute values are never less than negatives. So this is a case of no solutions. No x value will ever make this statement true. Now, just because I got a negative didn't mean it automatically gave us no solutions. Remember, you also have a case of all real numbers. But this is a no solution case. It gave me a false statement because positives are not less than negatives. Last example, we need to do the next problem, same idea. We're going to rewrite it. 3x minus 4 plus 18 greater than 10. We're going to isolate. You have to subtract 18 from both sides first. And you get 2 absolute value of 3x minus 4 greater than -8. Divide by 2 to get rid of that 2 in front. 3x minus 4 greater than -4. Now in this case, you may notice, hey, is the number on the other side negative? Yes. It is negative. So this is a special case. Now this time, my absolute values are going to give me positive numbers, and then I'm comparing it to a negative number. Are positive numbers greater than negatives? Yes, this is a true statement. No matter what number I put in here, let's say I put 10 again. 3 times 10 is 30, minus 4 is 26. 26. The absolute value of 26 is 26. That's greater than -4. So no matter what x value I put in here, it is a case of all real numbers. Because absolute values are always greater than negatives. So all real numbers. So you have to be careful when you get a negative. Don't always assume it's an all real numbers case. Don't always assume it's a no solution case. It really depends on your inequality symbol. So if it's positive, greater, negative, that's true. All real numbers. If it's positive less than negative, no solutions, because that's not true. And for these, we really don't have number lines because it's never true. So the main thing is, I think most of you are really good at just solving these. Make sure you know how to write your answers. So make sure you know, for an AND, these are the formats we're going to write our answers. And for my OR, these are the format that we're going to write our answers. If you have any questions, feel free to come to tutoring. Otherwise, good luck.